Good morning or good afternoon. We will be presenting fashion items matching to Dr. Mustafa Yusuf and Engineer Khaled Al-Tahan. We are Shahab Eddin Ibrahim, Yusuf Nasif, and Yusuf Hussein. We'll start by our problem statement, which is since the rise of mass production of clothing items and the boom in the fashion industry, people were left to choose between various products. Our project aims to facilitate that choice for users by creating a machine learning model that recommends the most matching fashion items based on user preference and fashion experts' insight. So the user inputs to the model a top, and the model recommends to the user a user bottom and a shoe while taking into consideration the item's visual and texture features.
Okay, so let's start by refreshing you guys on the original model we're working on, the PAI BPR. Okay, so let's just start by structuring the model a little bit. So basically we have multiple components here. We have the k-means color quantization, the tops and bottom attribute classifier, a feature extractor, a Japanese texture representation, multiple encoders that we use within our model, a user encoder, and the BPR itself. Okay, so this is the PAI BPR. This is the original model we started working on. So basically the model as shown here takes in 3 clothing items, a top, the item which we would want to match a bottom with, a positive bottom, and a negative bottom. To make things clearer for you to understand the terminology, positive here refers to items user has interacted with, while negatives here represent items that the user has never interacted with. By understanding this information, the BPR runs pairwise comparison using the top and each bottom to determine the best match, taking into account the learned user preferences and clothing item attributes. So in order to do so, some pre-processing is done to extract the visual latent representation vectors, which comprises of the k-means and the latent representation vector, which is extracted from the item image by the attribute classification network. Furthermore, texture features were also pre-processed, where every word in the item description is passed through the NWJC2vec, which is a Japanese word to vec, to generate a 300-dimension vector for each word. During training and prediction, the resultant textual and visual representation are passed through a convolution net and a simple encoder, respectively, and passed through the BPR along with the user embedding, which finally determines which bottom is better fit for that top given the user, and the item-to-item compatibility. Okay, so now we'll be discussing our proposed model upgrade. So we're calling it the Big PAI BPR. So basically, this is the model architecture we have implemented. So presented in front of you here is the Big PAI BPR. And so basically, the outer PAI BPR model has a few extra features, which we will now discuss. The big model uses the original PAI BPR to find the best bottom. The chosen I'm sorry. The chosen bottom's text and visual features, along with the tops, are passed through encoders to generate a compressed 512 vector representation of each, resulting in a top-bottom textual latent representation and a top-bottom visual latent representation vector. As for the positive and the negative shoes, they pass through the same visual and textual features extraction process as described before. The top-bottom combination as well as the positive and negative shoes are then passed through the VPR along with the user embeddings to provide us with the final recommendation of the output itself. Okay, so the major differences between our solution and the already existing state-of-the-art model is that our model not only recommends bottoms, but also has the capability of recommending shoes. Our model used Inception version 3 for visual features extraction for shoes, while the state-of-the-art used a modified version of AlexNet. Finally, the major difference is the extension we built around the model, which as we discussed, encodes the top and the chosen bottom by concatenating the representation vectors and passing the resultant vectors into encoders generating top-bottom visual and textual representation vectors, used for the BPR process of matching with shoes.
So this is a quick summary for the work done throughout the project. In milestone 1, we ran the k-means clustering model on the icon dataset and trained the ACN attribute classifier from scratch on bottoms and tops and started working on the proposed model. Then in milestone 2, we finished all the data pre-processing we needed to run the proposed model by developing a feature extraction model using transfer learning on Inception version 3 and successfully compiled and trained the state-of-the-art architecture, then started training the proposed model. And finally, regarding the final milestone, we were able to run the proposed model that takes a top and returns a ranking of the bottoms and shoes based on the user preferences and the item-to-item compatibility. Next. And here are graphs representing the area under the ROC curve of the Bayes model that was obtained on the test dataset. On the left, this is the curve presented in the paper, and the other one is the output of the developed model. Next. Then here's the results of the updated proposed model with the shoes retrieval on the left showing the AUC change with respect to the epochs, and right indicates the decrease in loss with respect to the epochs. Next. And we were able to obtain the final AUC of 0.61, and this can be much improved with stronger hardware resources with better memory and GPU capabilities to avoid copying large data. And here's a small demo of the working application. We have cropped a part of the video because the demo takes like 5 minutes to run.
To conclude, we acknowledge that the model accuracy could be much improved if we had the resources to do so. Our dataset and the model capacity were huge, and thus we had to trim 40% of our dataset. In addition, we could have used better Japanese embedding and finally using Inception model to extract bottom features to improve results. For our future work, we need to train our dataset on a better equipped machine since our dataset was big, as we talked about that. And in the future, we can collaborate with other brands to provide us with pictures of their clothing items. And that way we can expand our dataset and have a platform that can match items cross brands. Finally, creating a mobile app or a website to have a better user interface. And here is our member contribution. Thank you.